Hello students, today we are going to evaluate some integrals using Cauchy Integral Formula. From Cauchy Integral Formula we know that integral over C f of z by z minus z naught dz is equal to 2 pi I into f of z naught. If in the denominator the factor is linear, we can take this term as z naught and we have to use this formula when z naught is a point lying inside C. When z naught is a point lying inside C, we can use this formula. Now come to the problem. We are going to evaluate integral over C z dz by z squared minus 1, where C is the positively oriented circle mod z equal to 2. Mod z equal to 2 means already we know that the equation of a circle is modulus of z minus a equal to r, where a is the center of the circle and r is the radius of the circle. Here the given equation is mod z equal to 2. So z has the center, not z, C has the center 0 and radius 2. So C is a circle with center 0 and radius 2. They have mentioned the circle is positively oriented. Positively oriented circle means in the anti-clockwise direction we have to trace the circle. That is called positively oriented circle. Now come to the problem. If we are going to use Cauchy integral formula, in the denominator the factors should be linear. If it is linear, we can use this formula. But in the problem, we have a quadratic polynomial z squared minus 1. First, we have to split this into linear factors. Then we have to apply this formula. For that, what I am going to take is, I am going to take the denominator term separately. 1 by z squared minus 1. Here actually, excluding this dz, whatever term we have now, that we have to take as f of z. So obviously f of z is equal to z. Only we have to split this denominator into linear factors. So I have taken this separately, and using partial fractions we are going to split this into two fractions with linear factors. For that, first we have to split this. Tell me the factors for this. You know that the formula for a square minus b square, no, a square minus b square is equal to a plus b into a minus b. Here we have z squared minus 1. So which can be written as z squared minus 1 squared. So the first term we can take as z plus 1 and the other term is z minus 1. Since we have two factors, we have to introduce two constants in partial fractions. Let them be a and b. So a by the first factor z plus 1 plus b by z minus 1. And now we have to take the LCM in the right side. So a into z minus 1 plus b into z plus 1 by z plus 1 into z minus 1. The left side is z squared minus 1. Z plus 1 into z minus 1 is obviously z squared minus 1 squared. So we can cancel both the left side. So what we have is 1 is equal to a into z minus 1 plus b into z plus 1. Using this expression, we have to find what is a and b. Let me take the same equation. 1 is equal to a into z minus 1 plus b into z plus 1. Let me substitute z is equal to 1. So we are going to take z equal to 1. So when we substitute this, 1 is equal to, in this place when I take z equal to 1, the term will become 0. So a into 0 plus b into 1 plus 1, which is 2. Okay, so which implies 1 equal to 2b, which implies b is equal to 1 by 2. We got one value. For finding the other one, we have to take z is equal to minus 1. When I take z equal to minus 1 in this expression, I am getting 1 is equal to a into minus 1 plus b into minus 1 plus 1, which implies 1 is equal to a into minus 2 plus b into 0, which implies 1 is equal to minus 2a, which implies a is equal to minus 1 by 2. Are you clear how we are taking these values for z? See the factors here. Okay, take these values as 0. Z minus 1 equal to 0 implies z equal to 1. So 1 z value we have to take as 1. And take this factor as 0. Z plus 1 equal to 0 implies z equal to minus 1. So take the other z value as minus 1. On substitution of these two values, easily we can find what is a and b. Therefore, we have splitted 1 by z squared minus 1, that is quadratic polynomial in the denominator. No, we have splitted that as a value is minus 1 by 2. So minus 1 by 2 by, actually what we have is a by z plus 1 plus b by z minus 1. So a by z plus 1 plus b value is 1 by 2 by z minus 1, which can be written as minus 1 by 2 z plus 1 plus 1 by 2 into z minus 1. I can rewrite this as, I can take the positive term as the first term. So 1 by 2 z minus 1 minus 1 by 2 z plus 1. Now we have splitted this into linear factors. Now we are going to apply Cauchy integral formula. The problem given is we have to find integral over c z dz by z squared minus 1, which we have splitted as integral z dz by 2 into z minus 1 plus minus integral z dz by 2 into z plus 1. Okay, so now we have to use Cauchy integral formula for these terms separately. Before that, 1 by 2 is constant. No, so I can take it outside. So 1 by 2 integral z dz by z minus 1 minus 1 by 2 integral z dz by z plus 1. Let me take this as equation number 1. Now we are going to find these two integrals separately. I am taking the first one, integral over c z dz by z minus 1. In this, excluding this dz, whatever term in the numerator we have, let it be f of z. So f of z is equal to z, and this term is z naught. So z naught is equal to 1. The circle given is mod z equal to 2. That is a circle with center 0, 0 and radius 2. So radius 2. The circle is up to these points, right? And here z naught is equal to 1. Z naught equal to 1 means the point is 1, 0, this point. So it's clear that this point lying inside the circle, that is the interior of the circle, mod z equal to 2. Therefore, we can use Cauchy integral formula. What we have the formula, if it lies inside integral over c f of z by z minus z naught is equal to 2 pi I into f of z naught. F of z naught means here f of 1. So f of 1. Let me calculate this f of 1 separately. F of 1 is equal to, this is my f of z. F of z is equal to z. Therefore, f of 1 is equal to 1. Therefore, we have 2 pi I into 1, which is 2 pi I. This is the value for the first one. Now, let me do the second one. The second one what we have is integral over C z dz by z plus 1. The Cauchy integral formula is of the form integral over C f of z dz by z minus z naught. The term should be z minus z naught. Therefore, we can rewrite this term as integral over C z dz by z minus of minus 1. Plus 1 we have splitted that plus 1 as minus of minus is plus. Since we have the general term as z minus z naught, we are rewriting that. Therefore, now f of z will remain the same, that is z. But z naught is different. Previously we had 1, here it is minus 1. Obviously this minus 1 also, because this is minus 1. Minus 1 means minus 1 comma 0, the point minus 1 comma 0. That also lies inside the circle, that is, that also lies interior of the circle. Therefore, what we have is this is equal to 2 pi I into f of z naught. F of z naught means f of minus 1, which is equal to minus 1, which is equal to 2 pi I into minus 1, which is minus 2 pi I. Am I right? Okay, now we are going to substitute both the answers here. So which is equal to 1 by 2. This answer we got as 2 pi I. So 1 by 2 into 2 pi I minus 1 by 2 into this answer we got as minus 2 pi I. So minus 2 pi I. Therefore, integral over C, not f of z dz by z squared minus 1 is equal to this 2 and this 2 and this 2 and this 2, minus into minus plus. So we have pi I minus of minus plus pi I, which is equal to 2 pi I. Therefore, the answer for this problem is 2 pi I. Is it clear?